Hey everyone, how you doing? Welcome to What Up Clegg. This is the channel we talk about anything that comes across my desk. And today we're talking about getting into RC racing, how to choose the right equipment, part 2. So in part 1 video, we talked about choosing the right vehicle. In this video, I'm going to try to help you to pick the right equipment that you're going to need for that vehicle, as well as everything that you're going to need for racing. But before we begin, I will warn you, this is going to be a long video. There's a lot of information I need to share with you to help you make the right decisions. Now, if there's something in specific that you want to take a look at, feel free to jump ahead in the video and check it out. Now, the first thing we'll talk about is the electron speed control, also known as the ESC. So let me explain what electron speed control does. Just like in the title, it controls the speed of the motor. But not only that, it also is responsible to distribute power throughout the rest of the electrons in the vehicle, because the battery plugs into electron speed control. So now let's go over some of the key features that you need to look for while looking for the right speed control. So when looking for electron speed control, look for brushless electron speed control. Brushless is what the type of motor that you'll be using in your race car. Roar is an organization that has created rules and regulations for the RC racing world. Majority of the tracks out there follow these rules. Therefore, whenever you buy an electronic parts for your vehicle, components, what have you, make sure that it is specifically states that that component is Roar legal. Blinking mode is simply an LED that blinks to indicate that the timing on your electron speed control is set to 0. By adjusting the timing on your speed control, it allows your motor to go faster. So, a lot of stock classes do not allow any timing changes on your electron speed control. So, by having blinking mode, this lets the officials know that the timing on electron speed control is at 0. Majority of the racers out there in 110 scale use 2S batteries. Now, some on-road classes use 1S, but for off-road, they use 2S. Now, you want an electron speed control that has motor sensing capabilities. What this means is that your electron speed control can connect to your motor, and your motor will let the electron speed control know what the motor's doing. So the electron speed control gets the data from the motor by a sensor cable. Now, without the electron speed control getting this data from the motor, the power delivery to the motor from the electron speed control is not as smooth, it's not as effective, it's not as consistent. Unless you like having to count how many times you push a button, how many times the light blinks, and how many times you have to push the button again, and then how many times the light blinks again, I highly recommend getting a wireless programmer. A wireless programmer is a device that permanently mounts inside your RC car. It then plugs in your electron speed control. You control the programmer with another electron device such as your cell phone or a tablet. You connect to your programmer by using either Bluetooth or Wi-Fi, or basically whatever's recommended for that device. Now, what's good about this is you don't have to count buttons or count lights or anything like that. It's just a simple select on your cell phone, on your tablet, what you want to program. Now, some electron speed control brands offer another device that plugs into your electron speed control to program it. Now, I have found it that to be not as easy to program electron speed control, but however, it is pretty easy still. With the Hobby Wings, the Hobby Wing came out with 2 different programmers that plug into your electron speed control to program it. They have the one on the top left, they call that the card. And then they have the one on the bottom left corner, they call that the box. Now, I don't recommend the one in the top left-hand corner, the card reader. That is very difficult to use. I recommend the box. Now, these devices here, they do not permanently mount in your RC car. They just plug in, you program it, and as soon as you're done programming your electron speed control, you unplug it and you're set to go. Next, we have the motor. Here are some points to consider when looking for a motor. First thing you might want to do is head out to the track where you plan on racing and see what the top drivers are using. And while you're at the track, take a look to see what motor classes they run. Do they want to run a 21.5, 17.5, or 13.5? Most tracks will run a 17.5 and a 13.5. Now, the higher the number, the slower the motor. The lower the number, the faster the motor. Now, due to a brushless motor being faster and more efficient than a brush motor, you want to look into brushless motors. So here's a quick difference between a brush motor and a brushless motor. If you notice the brush motor, you notice how it has brushes on the back of the motor. Now those brushes are held in place with a spring. Now the spring puts pressure on the brush, which then puts pressure on the commutator, which in turn causes a lot of friction on the motor. So without going into great detail on how electric motor actually works, I'll just show you the biggest difference between them and how they're designed, so you get an idea of the differences in performance. So the brush motor on the left hand side, if you look at the bottom, you'll see the brush is actually pressed up against the commutator. Again, this causes friction, and it's going to cause a lot of heat. So when you have a lot of friction, you don't have as much speed. Now, if you look at the brushless motor on the right, there's nothing pressing up against the rotor, the part that spins. There's no resistance. It's almost free spinning. So therefore, you're going to get a lot more speed. So now, the upside of a brush motor is because it has direct contact with the commutator, the electricity has direct contact with it, you have more control over the power at low speeds. You also have a lot more torque. So these brush motors, you'll see a lot of brush motors in vehicles like rock crawlers that require precise power delivery and a lot of torque. Another great thing about the brushless motor is because there's hardly any contact to the motor, they last a long time. You can get over a year usage out of a motor, out of a brushless motor, if you treat it right, versus a brush motor. If you race with a brush motor, you'll be going through motors probably every month, depending on how many races you go through. You'll be going through motors about every month. You have to rebuild them, resurface the commutator, change out brushes, and so on, because you have the friction. The brushes are rubbing up against the commutator. That causes a lot of wear. So if you remember back when I was talking about electron speed controls, I talked about the benefits of having a sensored motor. So make sure when you look for a motor, you look for one that has a sensor port. Again, when you think back when we were talking about electron speed controls, I talked about timing adjustments and the blinking mode. Well, in most stock classes, you're not allowed to adjust the timing on the electron speed control. However, you are allowed to adjust the timing on the motor. Therefore, look for a motor that has timing adjustments. I don't recommend start racing adjusting your timing. I recommend that you practice a few races and get to a point where you're not crashing as much before you start adjusting the timing to make your car go faster. So here you can see the different locations where they put the timing indicators on motors, different brands, different models. Now the benefits of adjusting the timing to turn the timing up is your car will go faster, the RPMs, it increases the RPMs of the motor. The downside is you lose torque. So if you're on a big track where it's really fast, jacking the timing up is a good thing. If you're on a slower track where there's a lot of jumps, a lot of tight turns, keeping the timing down is better because it allows you to come out of the corners faster and allows you to punch the trigger when you're coming off a jump. If you don't have the torque when going off the jump, then your car has a tendency to nosedive. Also, if you turn the timing up too high, your motor will also get a lot hotter. And there is also a sweet spot that motors have. So if you set the timing too high, you could be making your car run highly inefficient. Now you're wondering, what's the fastest motor out there? What's the best brand? If you buy a motor that's around $100, you will be competitive. You'll be competitive right up there with the best of them. You do have those guys out there that will have the $200 motor that is certified, custom tuned, custom balanced, everything else. But if you notice, they're only going around the track maybe a second or two faster than the rest of the crowd. The thing is, as soon as you crash, all that extra $100 that they put in that motor is gone. So therefore, don't worry about going out there and getting the fastest motor that you can if you can't make it around the track without crashing. Up next, we have the battery. So here are the more popular brands that you'll find at the track. Now these batteries here, they range anywhere from $50 all the way up. There's actually one brand here that's a lot cheaper than the rest. It's the Awanfi. Now the Awanfi, they run just under $30. Or if you get a pack of 2 of them, they run about $55 for a pack of 2. If you're a beginner starting out, this is an excellent battery to start off with. It's not very expensive. When you go out and buy batteries, you're going to need at least 2 or 3 of them. You'll need one for practice, one for racing, and then you also have to make sure that you have one for backup. So you need at least 2 of them out there on the track. So the first thing you want to look for in a battery is that it is a 2S battery. 2S stands for 2 cells wired in series. So a regular LiPo battery will have 2 cells in it that are 3.7 volts each. When you wire them in series, you come up with 7.4. High voltage batteries will be 3.8 each. Therefore, when you put them together, you have 7.6. It's not really important to know when you're looking for batteries. You just have to make sure that you see it that says 2S battery on it. So going back to my first video, part 1, you'll see that I was directing all these components towards 2-wheel drive, buggy, off-road, because that is the most popular form of RC racing out there right now. So that's why I'm going over these particular components, the 2S batteries versus 3S, 4S, 6S, and 1S, so on and so forth. And also the shorty. At 110 scale off-road racing, all the buggies out there take a shorty battery. Therefore, you have to make sure that you're looking for the batteries that are listed as being a shorty. And here you see a picture between a shorty battery versus a standard length battery. So you want something with at least 4,000 milliamp hours. Each race is going to be about 5 minutes long. If you have a battery pack that has 4,000 milliamp hours, your buggy is going to be running approximately 12 to 15 minutes without any problem whatsoever. So you want something that lasts a longer time, because that means your voltage will continuously be higher. However, you don't want it to be too high, because the more milliamps you have, the heavier the battery. So for a C rating, you want to look at something about an 80 C. What the C stands for, I guess the best way to explain it is instant power, like instant burst of power. A stock motor is not going to require more than 80 C of instant power. It's just not going to happen. So if you can get more, you can get 130 C, 150 C, but you're not going to see a difference. You're not going to see a difference at all. If you're in modified class, well, then you want to move up to like 100 C. But for stock class, 80 C is all good. To plug your electron speed control into your battery, you have to have plugs. They're called bullet plugs or banana plugs, depends on the style that you go for. Here you can see where I've outlined where the plugs go. Now you have to make sure that you get the batteries that have the same size plugs. They have 4mm plugs and they have 5mm plugs. Either plug will be good when you're stock class. Modified class, they like to run a 5mm plug, but again, for stock class, 4mm plugs is all you need. But if you notice that little plug between the 2 outer plugs, that right there is your balancing plug. That's a 2mm. They're all the same size, but that is one where you'll plug your wire in for the charger for balancing the battery cells. Now here are the 2 style plugs, the bullet plug and the banana plug. Which one to use is pretty highly controversial. So here's where it gets controversial. Which one has the most contact when inside the port of the battery? So the bullet plug, it makes contact inside the battery at the very tip. That's why it's flared out. The tip is flared out. Well, after probably a dozen times of pulling them in and out of the battery, they start to loosen up. And so you have to go in there and you have to separate a little bit, and it's tight again. But you only have contact at the very tip of the bullet plug. On the banana plug, the outer part of that sleeve, I call it sleeve because it kind of slides back and forth in a shaft to allow it to expand and contract as the center part is squeezed in, but that's the contact area. Well, literally that one, the banana plug will make more contact because there's more surface. The only problem is because it goes back and forth on the shaft, it's not directly connected to the shaft, it's slide back and forth. It has a tendency to lose contact. So here's another picture again of the sleeve that goes up and down the shaft as the center part is compressed. So a while back, I came out with a video that showed how I remedied the problem with the shaft not making contact with the sleeve as it goes back and forth, because I have lost power on my cars because they would slide back and forth. But what I did to remedy the problem was, as you can see where I circled the joint, I slide the sleeve all the way down and then I solder that joint at the bottom. Now, because the sleeve is all the way down, it still gives the sleeve the ability to slide up and down at the top of the shaft. However, like I said, it is now permanently connected to the shaft by the solder. And I have never had a problem ever since. They never loosen up and they always stay tight. When looking for a battery, take into consideration a high voltage battery. A high voltage battery is 7.6 volts. A standard 2S LiPo battery is 7.4 volts. The 0.2 volts extra that you have on a high voltage is actually pretty noticeable, especially on takeoff and when you need that little extra punch and speed. And keep in mind that throughout the race, you also have more voltage throughout the race because you're already 0.2 volts higher in voltage than you are over the 7.4 volt battery. Here's something else to take into consideration when looking at a battery. You have a graphene battery and you have a non-graphene battery. The graphene batteries are newer technology. However, you won't notice really a difference between performance between the graphene and the non-graphene. It's more longevity. The graphene battery it allows more charges, has a longer lifespan. It lasts you over a year or so lifespan out of these things. It handles more abuse, such as you can discharge it at a higher rate, and you can also charge it at a higher amperage versus a standard battery. The downfall of graphene is they're a bit more expensive. As I demonstrated here, you have $85 versus $100. Well, the extra $15 you might not think is a big deal, but as I mentioned before, when you get into racing, you want to have at least 2 or 3 extra batteries, or 2 or 3 batteries total. So that $15, that starts to add up after a while. The charger. And yes, there are a lot of different variations of chargers out there. I would recommend looking for something that can run off an AC or DC power supply. Therefore, you can either charge your battery at home, or you can use your car battery to charge your RC battery. LiPo balancing is charging the cells in your battery, such as a 2S has 2 cells. It charges them to the same voltage. Make sure your charger has storage mode. You don't want to leave a LiPo battery at a low voltage or a too high of a voltage for more than 48 hours. A storage mode will put your batteries at an ideal level, at an ideal storage level, to allow your batteries to last longer. Dual charging is a really nice feature because it allows you to charge 2 batteries at once. Therefore, you don't have to wait around for one battery to charge before you charge the next. Now we're at the radio control unit, also known as the RC unit. As you would expect, here's a picture of the more popular RC units out there on the market. Although you only need 2 channels to operate your vehicle, you'll want at least a 3-channel system, and this is why. Well, first off, this is a 4-channel receiver and not a 3-channel receiver or 2-channel receiver. So a 2-channel receiver will have 3 ports. This port right here, it's a 4-channel receiver, therefore it has 5 ports. So you have a port for the steering servo, you have a port for the electron speed control, and then you have all the other accessory ports. On a 2-channel receiver, you only have 1 extra port because the other 2 ports, one's for the steering servo and the other one's for electron speed control. Then a 3-channel, you have 2 extra ports. A 4-channel, you have 3 extra ports. In racing cars now, you have a lot of accessories that you want to plug into your receiver, such as a capacitor for your steering servo. You want to plug in a cooling fan for your motor. You want to plug in your transponder or what have you. So having extra ports is a really good thing to have, really convenient. So you might be asking why these receivers look so different. The reason why they look different is simply because of the antenna. The one on the left that looks like a tombstone, that's the antenna. Where you have the one on the right has your typical wire antenna that comes out the side. The difference is the range of the wire one is a little bit more because you can have a taller antenna. However, there's no racetracks out there with a track big enough to where you need that type of range, where you need that extra range. So a lot of people like to use the tombstone style because it just looks cleaner. When purchasing an RC unit, make sure you get an RC unit that has a receiver with it. This will cut down on cost when you buy them as a bundle versus buying them separate. And when you get the unit with the receiver, make sure the receiver does not have the AVC function on it. This function is what they call active vehicle control. It's mostly designed for drag racing. It'll just basically automatically steer the car, keep the car straight. It's kind of like a gyro system inside of it. This is not allowed in off-road racing, and even if you did have it on, it just caused your car to automatically steer into a wall. How many vehicles will be controlled? In the future, how many vehicles do you plan on having? Do you plan on having a two-wheel drive buggy, a four-wheel drive buggy, a stadium truck, bashers, what have you? These control units can operate multiple vehicles. You can program multiple vehicles to these controllers. All you have to do is buy separate receivers. So this is where you have to decide on what brand you want to go with. Receivers, if you plan to have multiple cars, receivers can be very expensive. They can range anywhere from $15 all the way to $100. So if you're going to have 5 different cars, that's $400 that you would have to have in receivers, because you have to buy 4 extra receivers. Versus if you go with something like the Fly Sky, they're about $15 for a receiver. Now the Fly Sky unit itself is about $50. I know it sounds cheap, and a lot of people are very skeptical because of the price, but I tell you what, I know at least a half a dozen people personally that have this RC unit, and they love it. They've never had a problem with it. Worked flawless. So, something to think about. Do you want to pay $15 for a receiver? Do you want to pay $40, $50, $100 for a receiver? That's something you got to take in consideration when you're looking for a brand to get. Independent left and right steering adjustments. Make sure your radio system, your radio unit, has these controls. They're also known as steering end adjustments. Here's how it works. When you turn, let's say you're turning right, your tires will only turn so far before they stop. Well, that's where you want your servo to stop. If your servo keeps trying to push your tires past that maximum spot, you're going to burn your servo out. And the same thing when you're turning left, you have to be able to adjust it right to the maximum spot. The swing of the servo is different from left and right, therefore they have to have separate adjustments. And on that note, we come to the steering servo. Just like anything else in RC cars, there's dozens of companies out there that make servos. So here's a little breakdown of things to look for when looking for a servo. As you can imagine, with all the different scale sizes in the RC world, there are many, many different sizes of servos. So for 1/10 scale vehicles, you want to look for a servo size that's indicated as standard size. That is, the actual size is called standard size. The dimensions of a standard size servo is approximately 39.5 millimeters wide and about 20 millimeters deep. Most RC platforms, the companies try to cram a lot of stuff in a little space, so it's good to try to get components that are as small as possible. So in a servo, I recommend looking for a low profile servo. Low profile servos are in reference to the height of the servo. A standard height servo is about 36 millimeters to 39 millimeters, and a low profile is about 26 millimeters to 29 millimeters. A lot of the high performance low profiles, you'll be looking at about 27 millimeters. There is no change in performance when you're looking at a tall one versus a short one, so you don't have to worry about losing performance if you go with a shorty over a standard height one. So when choosing a steering servo, you have to take the speed in consideration. How long does it take that steering servo to go from all the way to the right to all the way to the left? And does it match your reaction time, and does it match how fast your reflexes are? When you turn your hand, that steering servo has to turn just as fast as your hand and just as far in the same amount of time. Look for a steering servo that has approximately 0.1 second or faster. If you're extremely fast, extremely fast, then you want something that's probably a 0.8 second, 0.7 seconds. That's just about the fastest they make them, and that's pretty stinking fast. Also, when you're looking at the speed, look at the voltage. Your speed control puts approximately 6 volts to your steering servo. So therefore, look for the speed with 6 volts. Along with speed, you have to take torque in consideration. When you're driving, you're turning into sharp corners, you're going to rough stuff, all that stuff can cause resistance to the servo, which then slows down the speed. You want to make sure that your speed is maintained high. Therefore, you have to have a higher torque level. About 125 ounces of torque is pretty good. That's a good place to go. I wouldn't go anything less than that. And also, at the same time, make sure, again, you're looking at it at a 6-volt power source. Now, let's go over tires. Just about the best and only way that you could find out what tire is best at the track is to visit the track. Talk to the people that are racing on it, talk to the owners. They will know better than anybody what the best combination is for racing on that track, on that surface. There are many different types of surfaces to race on. They have high traction clay, they have medium traction, they have low traction, they have carpet racing, and right here I have a picture of high traction clay. This is one of the more popular surfaces to race on, and not just the design that you have to look at, but you have to look at the compound. Is it soft rubber that you're going to have to use? Is it harder? Is it medium? These are things that you have to take into consideration. This is why you need to visit the track to find out what they're using. These tires here are mainly designed for carpet racing, but you can also use them on low traction dirt tracks as well. So not just choosing the right tire and wheel is just that easy. You also have to make sure that the wheels have the proper offset for your buggy, for your brand and style of buggy. You can find that out by the track, or you can contact the manufacturer of your buggy. They'll tell you what the offset is that they recommend. Also, when you buy tires and wheels, you can buy them in different configuration. You can buy the tire already mounted to the wheel, which is already glued, it already has the foam inserts, and so on. That's the route that a lot of people take because it's less messy. You don't have to glue them. It's already done, and you don't have to worry about them coming apart. You have to remember that also the tires have foam. When you purchase them separately, the tire and the wheel and the foam, you have to use foam inside the tires. This is like having air in your tires. It keeps the form of the tire in place and prevents it from collapsing when you're going off jumps or hard turns and stuff like that. But it's not just the foam that you have to worry about. It's the consistency of the foam. Do you want it to be soft? Is it going to be better hard, medium, so on? These are all things that need to be taken into consideration when you're looking at wheels and tires. Now we're getting to the exciting part, the performance upgrades. So the first thing that people usually say when they get into RC racing is they want to make their buggy or their vehicle as fast as possible. They want to make it the fastest on the track. Again, the speed of the car is not what wins the races. It's the skill of the driver. If you have a car that's too fast for you to handle, you're going to spend more time waiting for your car to get flipped back over because it'll be crashing than you will actually driving. You can make your car, put every single hop-up part on your car, make it as fast as you could possibly make it. You're probably only going to shave maybe 5 seconds per lap. Well, each time you crash, think about how much time you lost because your car crashed. You crash once, that whole 5 seconds is gone. So those hop-ups don't mean anything. Once you get to a point where you can handle your car, you can make it around the tracks majority of the time without crashing, then you start looking for ways to make your car faster. Remember, you're going to hear it all the time. Being slow and steady will give you a faster time. So with that said, here are some of the hop-ups that more likely you will need to get into racing. So this upgrade here is the first upgrade that every racer will make. They're adding weight to the vehicle. Right out of the box, your vehicle with all the components on it and ready to go, it's going to be under the ROAR legal weight limit. Therefore, you have to add weight to it. Now, adding weight, you can add weight in the front, you can add weight in the middle, you can add weight in the back. It all depends on what type of handling characteristics you were looking for. Therefore, you'll have to take your vehicle to the track, drive around, and see what it is that you want to change, where you want to add that weight to get the handling that you are looking for. This here is also an extremely popular upgrade to make to your vehicle. Just about every racer does it. It's a cooling fan for the motor. If you have what they call a motor that's timed out, where you take the time and you turn it all the way up, and then you also add taller pinion gears on it to make the buggy even faster, the vehicle faster, chances are you're going to get that motor really, really hot. Now, if you get the motor too hot, number one, you're going to ruin the motor. Number two, it loses performance. So you want to keep the temperature in a sweet spot. You can find that out by contacting the manufacturer of the motor. They'll let you know what temperature to keep it at, and so on. So this right here, again, is a really popular upgrade and something that you want to look into. These are called chassis skins. It's like a sticker that goes on the bottom of the chassis of your car. These are designed to keep the bottom of your car from getting all scraped up whenever you go off a jump or whatever and it hits and you bottom out. You end up bottoming out. Also, many carpet tracks require these on the bottom of your vehicles because it prevents the bottom of your vehicle from wearing out the carpet as it bottoms out, from going off jumps and big bumps and so on. This is a capacitor. This capacitor is designed for steering servos. This plugs into the receiver on your RC vehicle. Your steering servo is a high power servo. So when it first starts to turn, there's a power spike. Well, this capacitor supplies the extra power that servo needs when it initially starts to move. This right here will allow movement of the steering servo to be a lot smoother. Extra parts, tools, and miscellaneous items that you'll need. This is the last section. However, sit back and enjoy yourself. It's going to be a long one. So if you're just getting into racing, you probably know that you have to prepare yourself for a lot of crashing. Due to these vehicles being so fast and so powerful, chances are you're going to break something when you crash. Therefore, you have to make sure that you have a good supply of parts on hand. Suspension arms are the most popular items that break when getting in a crash. They're the furthest out there, and they're also considered the weakest point. They do have different suspension arms that are made out of different materials, such as they have ones that are made out of carbon, and they have the regular plastic ones. I would recommend getting the carbon ones when you do crash and replace them. They'll last a little bit longer. Shock shafts are another item that gets broken a lot. They usually get bent in high-speed crashes, and again, these RC cars are very fast. Shock springs don't really get damaged in accidents, but I have them on here for spare parts because you will need different thicknesses, different stiffness shocks for the front and rear of your buggy to adjust the handling characteristics of your buggy or your vehicle in general. Pinion gears don't get damaged in wrecks either, but sometimes they get damaged from a rock, or sometimes they just end up coming loose and fly off on the track. So you want to make sure that you have at least two of each pinion gear. You want to make sure that you have different variations, different tooth sizes, because it depends on the type of track layout that you have. If it's a tight track with a lot of jumps, you want to go slower because you want the torque. But if it's a high-speed track, big track, then you want to gear up because you want to go faster. Tie rods are another item that gets damaged a lot in high-speed wrecks. You don't have to go out and get the titanium ones, but it is good to have at least one set of extra tie rods in your box in case you do happen to get in an accident and bend one. So let's go over some miscellaneous items to add to your box. Extra wire is good to have in your box. You never know when you want to reconfigure your electronic speed controller in your motor. The type of wire you want to get is something that's high strand, very flexible, silicone coated, and it must be of a high quality wire. Gauge wise, if you're running stock class, 14 gauge is absolutely fine. If you want, you can go 12 gauge. There'll be no harm, no foul. But again, 14 gauge is perfectly fine. You'll need a set of bolt plugs or banana plugs, whatever design you decide to go with. You'll need these to solder on your electronic speed control to plug into your battery, but you have to make sure you get the right size for the plugs that go into your battery. Your batteries, they might be a 4mm, they might be a 5mm. Just make sure you get the right ones. This is a charging cable. This goes from your battery to your charger. This includes the balancing plugs as well as the battery plugs. Now your charger, most cases they come with the cables, but the cables that they come with are pretty short and pretty cumbersome to use. These right here make charging a lot easier. You also need a couple of different types of grease. You need grease for the gears in your gearbox, and you also need grease for the ball bearing diff in your gearbox, if you have a ball bearing diff. You will also need different types of shock oil and different types of gear differential lube. The oil for the shocks is to control the speed in which the shocks move. So you'll need different variation types of oil for that, because depending on the track will depend on what type of oil you use. Now the lube for the differential, that you'll also need a couple of different variants types of thickness, because you want a different stiffness and resistance inside your gear differential on certain types of tracks. Now we're on the final stretch, tools and accessories. The main tools used to work on your RC vehicle are Allen drivers as well as nut drivers. If you don't know which ones that you'll need for your vehicle, when you order a vehicle or purchase one, you can find out right there from the hobby shop what they are, or you can look it up online and they'll tell you what size you'll need. But you'll need to make sure that you get a good set, especially Allen drivers, because a lot of times the bolts are really hard to put in, the screws are really hard to put in, and they'll strip out the tip very, very easily. But you also have to make sure if it's going to be standard size or if it's going to be metric size. A good soldering station is very important. You want something where you can adjust the heat. But when you get one, you want one that has a heat register of at least 400 degrees or higher. That's 400 degrees Fahrenheit or higher. A charging bag is something that's really important to have. As good as LiPos are, they have been known to catch on fire when they're going bad and while charging. Some facilities, racetrack facilities, will not even let you charge your batteries there unless you have a LiPo battery bag and the battery is charging inside the bag. So make sure that you have a LiPo bag. LiPo bags, what they do is they contain the flames. They're fire resistant, so therefore the flames don't spread and catch everything else on fire. A car stand isn't really a need, it's more of a convenience. It comes in really handy when you're testing your speed controller out the speed and you're adjusting the motor and you have to turn the tires and spin the tires. It also allows you to be able to spin the car around as you're making adjustments to make sure that everything's even. Having a car stand that has a parts tray underneath is very convenient, because it'll help you keep the parts in one spot and prevent you from dropping them on the ground or losing them. Helping hands are good to have, or any type of alligator clips, because it keeps wires in place as you solder them. Therefore, when you pull the heat away from it, the wires stay and cool and they don't loosen up and get messy. It's very important to have some type of storage container where you can organize all your parts and all your tools, so it makes it very easy to find them when you need them. When you go to a racetrack, you want to be able to take them there in some type of transportation container or bag. You can use a big duffel bag if you like, or you can use some specialized transport container that are used specifically for RC cars. However, those are extremely expensive just due to the fact that they have some RC car name on it. But you can use anything from a tool tote to anything that you find convenient to use and easy to use. Shrink tubing is very important because you want to make sure that you cover all exposed wiring. Shrink tubing also is very handy for help to organize wires, because you can put multiple wires in one shrink tube and then that keeps the wires nice and tight and clean looking. Your RC car body is going to come to you clear, therefore you're going to need some paint to paint it. Whether working on your vehicle at the track or working on your vehicle at home, you're going to need some type of a flat, clean surface to work on your vehicle. You can either use a padded work mat or you can use some type of a towel. Towels are nice because they prevent parts from sliding on the ground and rolling on the ground as well. Well, this concludes my presentation. I hope it is highly informative for you. And always remember, when you're out there racing, speed is not the fastest way around the track. Skill is the fastest way around the track. So I wish you guys a great deal of luck in your quest to reach the top of the podium. And I hope one day you become the next Masami. Thanks again for watching my video. If you enjoyed it and it was highly informative for you, please like and subscribe to my channel. If you didn't like it, subscribe anyway, just so you can make fun of me. Thanks, guys.